For the previous two questions, we already learned about 2D couple moment. So now for the third question, we learn about 3D couple moment. Okay, the question is determine the couple moment acting on the part shown in the figures, and the segment AB is directed 30 degree below the XY plane. Takes OA equal to 8 inch and AB equal to 6 inch. So we have 25 pound here. So we have 25 pound here. Okay, so for the 3D couple moment, so the equation is R cross F. So you need to know the what is the R in vector form and also F in vector form. Okay. Another equation that you can use is using dot product, that is F dot D. Okay, this is for vector and this is for scalar. So let's try both of them. Okay, first we try using this R cross F. Okay, for R is distance from head to tail of the process. Okay, for example here, the R is from this point. This is the head of, for example, this is F1 and this is F2, the head to the tail of the force. So this is R. Okay, you need to okay, from here to here, what is the vector? Okay, this is the x, because from here the figure not give the value of the x and z. Okay, so R equal to xi minus zk. Okay, so we need to get the value of x and z here. Okay, what the diagram give is, okay, here is 30 degree and the distance of this is 6. So okay, this is z and this is x. Okay, x equal to 6 cos 30 and z equal to 6 sin 30. So you will get 6 cos 30 equal to 5.2. This is inch, and 6 times 30 is 3 inch. Okay, so you can put here, so 5.25 minus 3k. Okay, and then F is unit vector of the force. Okay, unit vector of the force. Okay, you have dz, because it is only at the z direction. over D. Okay, what is the D? D here, dx is 0 because here only from here only go up, so there are no x value. Y also 0. Therefore dz is from here to here is z value that we calculate before. So z is 3. So dz over d, because same, so it was 3 over 3 multiplied by 25, so you will get same 25. This is z is k direction. Okay, so you have z equal to 3, x equal to 5.2, so the r is 5.2 I minus 3G, 3K. Okay, and the F is 25K. Okay, so this one cross product, so you will have R is 5.2, 0, negative 3, 5.2, this one is 0, and F 0, 0, 25, 0, 0. Okay, so you will have positive here and negative at the bottom. So okay, so the for I, 0 multiplied by 25 is 0I, and then minus 0G minus, okay, actually this is positive, but the value is negative, so that's why okay, I think it's better here, plus. Okay, and then okay, let's look for at the bottom, minus 0k minus 0I, then minus 25 times 5.2 G. So you will have the answer is negative 130 pound each. Okay, in G direction. Okay, to make sure the answer, you can imagine here when, okay, the magnitude is 130, and to make sure the negative and the axis, okay, you can see here the, okay, let's assume that you have your eyes here, and you can see the, it's like this, the axis is like this, where the force for the F1 like this, F1, and another is F2 here. Okay, and then you can connect both poles. Okay, and to know what is this direction. This is counterclockwise, and counterclockwise, therefore that's why is negative. And the axis, okay, from here, this axis, okay, you can see this moment. And what is this axis? What is this axis? This is J axis, so that's why it's J here. Okay, another method to solve this is using F dot D. F dot D here, what you need to understand, D is perpendicular distance. So what is the perpendicular distance here? Okay, like previously, you have to imagine you see from this side, so it will be like this. This is x-axis, this is z-axis, and the force is here, and another is here. Okay, when we expand this, the perpendicular distance is here. Okay, and when you see from here, what is this D? D is equal to x. So the value of f dot D equal to 25 multiplied by 52. So it's same. So you will get 130. So but as you learned before, for cross you can get magnitude and direction, and direction. For dot product, you only have magnitude. So this is the magnitude. So this is the magnitude. So how to get the direction? As I told before, you can see this is clockwise, so that the clock is a negative, and the axis of this clockwise is J. So that's this is how you can use another method.